Hey, Tim.
Hey Sage, good to see you again. I don't
Yeah,
have a
good to see
camera,
you.
sorry.
Oh, good to hear you. How's everything going for you?
Yeah, good, good. Um, um, I'm a bit vague today. I woke up way too early, but no, things are good.
Yeah, I know how that goes. Um, all right, let's see.
Had a good chat
With you there?
my headset just went funny.
Oh, sure. Sorry, you said you had a good chat with.
On orchestrator stuff the other day. With Juan Miguel Olmo Martinez, whose name I have probably totally butchered.
One Miguel or one me,
Yeah,
I think.
yeah,
Yeah.
yeah. So it looks like um, what I'm trying to do for the deep sea orchestrator module and um, what's going on the Ansible side are more or less following the same or a similar approach and similar trajectory. Um,
Oh, good.
so
Okay.
we're all we're either all doing good stuff or at least we're all crazy in the same way.
Let's. We'll hope it's the former.
Yeah, yeah.
All right. All right. I think it's going to be a pretty small crew tonight. Did you follow the Blinky Light thread?
Vaguely. Um, um, I saw some things about using lib storage management, and then ultimately probably a decision to um, that we need to call this out through the orchestrator somehow because we need to be able to blink lights if Ceph itself is busted or is not installed somehow. Um, I thought was the outcome, but
Yeah,
I may have missed some
exactly.
pieces.
Yeah, that's totally it. Right, so let's here because I think there aren't too many real decisions to make. But so in Nautilus, we have all the device tracking now. Um, all the monitors and the OSDs are both reporting what underlying under hardware device they're consuming as a
Yep.
model underscore or vendor model serial. So that's good. So I think at the user level, I think there are two commands that we want. One is turn the light on or off for a device, and then it'll
Yep.
find that physical device wherever it is and turn the light on, or do it for an OSD. In the OSD case, it'll do either the main device or both devices. I'm not quite sure. Would want to do
Yep.
it. I think and then under the covers, it's just a LSM CLI and then the path name to turn it, and then you tell it whether it's the fault LED or the ident LED and whether to turn it on or turn it off. The problem is all the state is like in the hardware. Um, so I'm trying to figure out what the like what the high level tracking is that state is that Ceph wants to keep track of.
Yeah.
So it could be that Ceph has a table of all the devices that have lights that are on, and when they're on, there's a corresponding health alert. So just so you know that there's like a light that's up. Um, um, the trick is that if say you turn a light on Ceph like makes a persistent record that the light is on and actually turns it on, probably turning it on and then recording that it should be on now. And then you like
Yeah.
reboot the box or something. Then Ceph will say the
Yeah.
light is on
Then
and the light won't.
yeah.
Uh,
Yeah. That was going to be
but
my immediate question.
I think that's maybe okay, because it's better to have Ceph think the light is on and have the light not be on than the other way around. Because you don't want to be in a situation where I turned on one light and I see a light on. Ceph says there's one light on, and you go and you find one light on, and therefore you like pull the wrong disk. It's the wrong disk. So I think
Yeah.
if it's like on the on case, you would turn on the light honestly and slow, and then record that the light is on. And then when you turn it off, hold off, say, you would record that the light off, or no, you
Yeah.
would you do you would turn it off. I guess I got this backwards. You'd record that the light is on, and then you would turn it on. And conversely, you would turn it off. Okay. Make sense? So the worst
Yeah.
case scenario, Steph would think the light was on, but it wouldn't be.
Yeah. Which is
If
much
you
better
like
than
hit
the
Control C.
alternative. Yeah.
Yeah.
Um. Yeah. I have a nasty feeling that this is always going to be slightly fuzzy because of what you just meant, the scenario you just mentioned, and also I don't know, I'm twitchy about certain BIOSes and things exposing lights in the right way, but
Yeah. Yeah. I mean, at the end of the day, you're kind of like relying on the hardware to like not be wrong.
yeah,
But I mean, that's at some level you just have to, yeah, you have to trust that it's
yeah,
gonna do it
yeah,
or not.
yeah, totally.
And then
Yeah,
if it doesn't, then you got to go upgrade the storage management. So it seems to me like this is pretty easy to implement. We need the layer, the calls in orchestration module to run LSM CLI or whatever other command is appropriate.
yeah,
And I think we need flags for on enter to record, but for devices with lights on off. And then health warn when any lights are on. And it'd be like health device light ident on. 3 devices have ident lights on, or device on. 2 devices have on. Something like that. Does that seem reasonable? Are you there?
yeah.
You might.
Sorry, I'm just
Yeah.
yeah. I flicked to another. There was some. I flicked to another tab. There was some chatter from uh, Dan and Jason saying there's some people on another meeting right now.
Oh, they're in a different room.
Yeah, the wiki and the calendar both point to a different room.
God damn it. I gotta fix that. Do you mind telling the other people in the other room to?
Yeah, we don't have a moderator, but Dan sent a chat message, so.
Oh, you're in the chat. Okay. Okay. That's annoying. All right, we'll fix the wiki. Planning.
Yeah, so to your question, yes, calls in the orchestration module to do something to turn the lights on. Good. I agree that it's sane for Millennial Manager to record at least what lights are on. It probably doesn't need a whole set of what's on or off. Just what's on is probably enough. And yeah, health warn when lights are on, because then you know that you've lit something up and you need to do something about it, and you won't forget.
That's good. And then the OSD, there's a question: if the OSD maps to multiple devices, should it only turn on the main device, or should it blink all of the devices, including like the shared journal and the?
Mm-hmm.
I'm kind of thinking it should only light up the main device.
Well, if you light up the main device and you, if you want to rip the main device out, awesome. If you also went and ripped out the journal device, then you're potentially taking down a bunch of other devices as well, which is
exactly
bad. Would there be any sense in having an option to also light up the journal, with the understanding that the administrator was very careful?
Maybe we could have an argument in the OSD case where it's you tell which one, like main, journal, or all, and you specify, and you have to specify.
Yeah, I mean the default you would totally want the default to be just the OSD, and not the journal, because you don't want to accidentally pull a journal device out if it's got multiple devices on it, multiple OSDs on it. So.
And it'd be journal, DB, wall, or all would be all the choices. Primary, maybe primary. Okay, that way it's explicit.
Yep.
And you have to specify. Can't get away with not saying.
Yep.
Okay.
Actually, just looking at that pad, we've got Ceph OSD ident on, and the next line is Ceph OSD fault off.
Yeah, it's either. It's one of the two, ident or fault.
Okay.
There are two types of lights.
Cool. Gotcha. Oh yeah, of course. Sorry. Yep.
And I think I said in an email, in my case, on my chassis, I think the fault one would blink, and the other one didn't. I can't quite remember. Ident was blink, and fault was solid, or whatever that's worth. I don't know if that's consistent or not. That's just what the Supermicro did.
Yeah, I'm not sure. I don't have any. I don't have any interesting hardware here, so.
Probably depends on the vendor.
Yeah.
Okay. Well, that seems simple enough. The Ceph code, I think, is pretty trivial. And on commands, measure commands. And then there's orchestrator part. Sounds good. All right. All right. What else do we have on the list? Who do we have here? It's a pretty short group. Let's just jump to the clay and erasure code stuff, Mina, since you're here, and do a status check there. You ready to go?
Hi, Sage.
How are you doing?
Can you hear me?
Yep.
So the code is right now in master code base. So I just wanted to know if there is anything else to be done. There is a unit test and the Ceph erasure code corpus right now.
Right. Okay.
And the documentation.
Sorry, go ahead.
And the documentation is also up.
Did that one merged? The documentation one merged?
Yes.
Yes. Yeah. Okay. I think it's basically done then. I also expanded the toothology QA definition or whatever to cover it. So the QA runs are exercising it. I think maybe the only thing that we want to do is figure out how to mark it as experimental for the next release, just because it's new and it's sort of critical to like not losing your data. But otherwise, I think all the pieces are there.
Okay, yeah, that's what I want to confirm.
Okay. Yeah, I think probably like what actually needs to happen as the next step is for somebody to like get motivated to do some like performance tests, like actually deploy it in a largish system and put a lot of data in it and like just see how it works and compare it to the other ones. That sort of thing. The final implementation. Probably repeating some of the experiments that you did when you wrote your paper originally.
So there is
But with the
some
final
difference between, so the paper, I think the paper one would have been faster because it was not a generic plugin. We were using it within JErasure.
Okay.
So right now we made it more generic in the sense it could use ISA or
Oh,
JErasure
right.
or HEC. So I'm not sure like how much delay that would add. And
Yeah.
because we had access to JErasure, things were a little bit easier in the sense that if only one erasure is there, we were just rebuilding that.
Mm-hmm.
In this particular case, because we are calling this erasure code plugin as such, it there
You're
is a
going through
little bit of
multiple layers.
redundancy. Yeah.
Yep. Yep. Okay.
So that's yeah.
Yeah. Well, I think we should give it a try. I'm not, usually I would sort of sign markup for that. He's pretty busy with a bunch of other stuff right now, so I'm not sure that he's going to get to do that pretty soon. But maybe it would be worth sending an email. Well, here are two things that we could do. One would be send an email to the development list, just like announcing it, and users list actually too, just saying this is merged and this is why it's cool, this is what it does, and very interested in feedback on like performance and so on. The other thing, if you're interested, it would be awesome if you wanted to write a blog about it, about the whole thing, on the Ceph blog, and you can talk about the code, you can talk about the process of getting it upstream, you could talk about the paper, you could talk about whatever you want to talk about, honestly. But if you're interested in that, always looking for people to contribute content, and happy to sort of get that out in front of people. Or you can do nothing. That's fine too. And we'll hope somebody picks up.
Sure, I'll let you know. Like if I have
Okay.
such plans, I'll let you know.
Yeah. Okay.
Thank you.
All right. Sounds good. All right. All right. Should we do let's do the RBD shared cache, read-only cache updates. Is you on? You're here?
Hey, Sage.
How you doing?
Hey,
And I
I'm
think
good.
we have Jason too.
Okay, so hi everyone. This is Yuan from Intel. So I'm going to give you some updates on the shared hour cache. So I'm going to load my
Yep. Okay.
Okay, so I actually provide a short slides for this. So first, I will try to give you some basic idea for the shared hour cache. So basically, it has three components. The first one is we have a cache daemon on running on each compute node, which can actually do promotion on the on each lookup, and also do some eviction when the cache space is under some high pressure. And the second component is we actually have a mini caching store for this, which is actually very similar like a file store based layout. it also supports subdirectory to solve the lots of small file issue. And the third one is we have a new librd hook that exists inside librd, which can redirect the read request on clone image to our shared cache. So this is the basic architecture or components for the current project. And this is the general airflow for the shared cache. So when there's a read request that flows to object dispatcher, object dispatcher is a new component designed by Jason Dalliman, things Mimic. So it's actually working on the object level, and with this dispatcher, we actually can do some very easily integration with our shared cache. We actually have a shared object cache dispatcher here, which can redirect the read request to our cache daemon. Basically, just look up in the cache daemon first, and if there's a cache hit, and it will just try to read from the local caching objects. If it is not hit, then the RBD caching daemon will try to will actually kick off async promotion request, just that tries to read the object from the Redis tier, and then store the objects to the local SSD. So this is a detail. This is a detail promotion flow. So when there's so here's several numbers here. So the most important one here is on the second step. If RBD decides, so RBD has an internal object called object map. Then with this object map, we can easily tell if it is okay to read from the parent image or not. So if RBD found this object is able to read from a parent image, it will just go to the cache daemon first to do a lookup there, and cache daemon will look up in our policy, which is actually a very simple ARIO based policy right now. On the first, just it will try then kick off asynchronous promotion from the Redis tier, and it will not block current read request since we are just returning a -1 here. So the object dispatcher will just try to flow to the next layer, which will be the core RBD layer. So the read request can still be serviced quickly here. And then after the promotion is done, it will try to the cache daemon will try to update the local metadata, which is actually a hash map stored in memory right now. For future reads, for future lookups on this object, then it will be hit.
So that asynchronous I/O is actually happening in the RBD code, right? Like the IPC to the cache daemon is just saying, do you have this object? The cache is saying no. And so RBD will proceed as usual. And then when it actually completes the read, it'll say, since the cache didn't have it before, I'll give it cache.
Yeah, that's right.
Does the cache have an option to like say, I don't have it, but I don't want it? Or do we always add?
We do have a policy model here that can build your own policy. For example, so currently we have a very simple idea here. We just promote on the first lookup, but we can further extend this to some more complicated one, like we can do promotion only when hit for 10 times or something like that.
Yeah, like an even or something. Yeah. Okay.
Yeah. And this is for the demotion flow. It's just like eviction. So the current eviction implementation is we just check the space. If it is above some watermark, we then do eviction. Simply remove some objects from the caching store based on the AIO status. We just remove those code objects.
Okay.
This is for the read hit, so I'll just skip that. For the write, it's since IBD has the mechanism to detect which objects are able to. So via with IBD's object map feature, so we can easily tell which part is copy on write. So for future reads on those copy on write parts, it will not go through our cache, but will read from Rados directory. So we actually have a PR here. In this PR, we have those general components implemented. The first one is the file-based caching store, which just tries to promote the object at the 4 mega level, and then just tries to store those objects into that caching store. It's very similar like file store. We actually have a subdirectory there. The default number is 10. So for those, for example, if we have a 128 giga IBD image, then it will be like 32768 objects. Then we're just hashing those objects to 10 subdirectories. In this way, we can release some pressure on the metadata side. And contrary, it just uses a synchronized read-write interface. We do plan to move this to libaio. And the second component is for the standalone cache daemon. So Jason actually suggests us to move this daemon to Ceph space, Ceph namespace, so that we can reuse this daemon for future Rados gateway cache. So basically, this is
RBD cache. You call it stuff cache or something.
Yeah. So the daemon is actually independent for those clients. I mean, RBD can register it as some clients. If we have some Rados gateway hook, we can also use this daemon to do the promotion, eviction, something like control the cache space. So it's reusable for Rados gateway. And then the third one is we have a configurable policy. For now, we just have a simple policy, a very simple policy based on ARIU. For each read, for each lookup in the cache controller, we just update this ARIU, and then when the cache space hits some watermark, we just remove those code objects based on this ARIU. So there are some missing points. Like I said, we're still using sync pread actually. The better way here is to use libaio, but we're still working on that. And then the third one, second missing is we currently only store those meta files as an in-memory hash map. And then if we restart that cache daemon, then the cache will be actually cleaned up. Yeah. So if we can persist this cache meta file, then we can actually save some time to warm up those cache. Okay, so I'm going to show some initial results here. So this is a warm cache test case. The setup is like 3 OS nodes, each with 7 HDDs with BlueStore DB and OR are co-located on the same HDD. And then on the compute node, we have a NVMe disk as the client-side caching. It is actually a P3700 SSD. And then here we actually use 16 cloned image on one compute node. So with 4K random read, FIO on if we use no caching here, then the IOPS is like 235. But if we have a warm cache here, the IOPS is going to improve like 7.7K here. The performance improvement is quite huge, and also just because it's actually just reading from local NVMe device. And also the tail latency has been saved a lot because we are on an HDD device. So tail latency is always a big problem for HDD. But if we have a client-side caching, the latency can actually be improved a lot.
So I wonder if the test to do here actually is, or maybe you have more results to show, but the one that
why
don't you go ahead?
So here's a simple picture that shows promoting the FIO performance with caching promoting in progress. So initially the performance is kind of low, like nearly the X ray here is IOPS, and the Y ray here is the time seconds elapsed. So as time goes by, the cache is being promoted more and more. And then during the first stage, the IOPS is like I should say the IOPS is like 200, a bit same level as the IOPS without caching. But as time goes by, the caching is becoming more and more promoted. So nearly at 200 seconds later, the cache has been fully promoted here. The IOPS can actually goes to 40K. So when you have a fully promoted cache, the performance is actually very stable.
Might be nice to see like superimposed on that graph would be like the without caching case.
Oh, right. Yeah.
Because if like without caching, it starts off at like 5,000 IOPS, something like that. But like with caching, like you kill your performance until it like actually populates the cache. Just for that comparison.
Okay. I actually have those data. I can send out later. But the we can expect the number here is like maybe like 300 IOPS because it's a HDD based cluster.
Yeah, so that was what I was going to say. I think that the interesting test would be what the cost of enabling this is when you're always missing the cache, I guess. So basically, if you just turn off promotion, but it has to like check with the cache every time and see what the penalty is for that.
Because if you're doing like 4K reads but then you're already saturated in your hard drive, and the background is basically also trying to saturate your hard drive with full 4 megabyte object promotions. So it's like pulling performance away from your cluster to do a full 4 megabyte object promotion for every single 4K random read you've done. It's just going to be
right.
Oh, I see your point. So, that may be some bad case. So when your cluster is fully saturated, then the extra promotion that and also it's actually a large read for the cluster that may be very slow, I think.
Yeah, I'm wondering what the how would we control that? Would you want to like have a just a max promotion rate, like a throttle, that way we'll no more than 50 megs second or 10 megs per second.
A maximum, I think, megabyte per second limit, I think would be.
Right. We should. So currently it's very wild here. You just do a wide promoting on each lookup. We do have some parameters to limit the in-flight IOPS, but I haven't tested that yet.
So the objector at least will like throttle you down at like 1,000, so you know you're not going above that, or like 100 megabytes after the default limit.
Okay.
So you might be hitting that like right at the get-go if you like send out, enough format read that you start hitting that objector built-in like throttle.
I see. But we actually can implement that because we actually for each read we actually have to do a lookup first, and then we can actually do some mechanism there to limit the promotion on each on the corresponding lookup.
Yeah, I think that'd be great.
Okay, so I think this is the general updates for this CDM.
So I have a couple other questions. So I think it makes sense to rename this so that it is a little bit more general, so that it could be used by something else. So I'm not sure exactly when that's going to happen. But the other question is, there's going to be some configuration option that like controls how big the cache is. Example, how much space it's going to consume.
Oh yes. We. So I forgot to mention we have a few options to do this. We currently use cache entry structure, similar like the cache limiting in the existing object cacher. So the entry stands for number of caching objects. So if you have 1,000 entry, then you are going to have like 4 giga cache.
Mm-hmm.
So this is our.
So there's with the Ceph config options. I wonder if we want to figure out how to tie this into the centralized Ceph config stuff that's stored on the monitor.
Doesn't that happen for all? Doesn't that happen for all clients?
Yeah, but this isn't really a client, right? This is like a different thing.
Well, it's a daemon, so it actually would be a client.
Does the daemon actually connect to the Ceph cluster at all, or is it just?
Yeah, so the daemon is actually what does the read to pull the data down from the last I saw. The daemon does actually kicks off the AI read.
I see. I was thinking that the actual RBD client would do it and then provide the data.
That's why like the shim to like the RBD world in theory is so simple and whatever. It's like, do you have it? No, but in the background, the daemon is
like, maybe I should get it.
Yeah.
Okay.
Or if you have like also, because the other issue is like if I had 6 librd clients all on the sharing the same cache on the same image, does the daemon tell all 6 of them to go fetch it for it, or like does it pick one? What if that one gets shut down before?
Yeah, exactly. Right. Yeah, that makes sense. Right. Okay. So in that case, we could all call them like client.daemon. Whatever, so that they have the client name is different, and so then the Ceph config, you can do Ceph config that client.cache daemon, and you could set that on a per host basis in the little selector thing for the configs. You could say host equals foo, maybe host a different amount of disk space. I think that would work fine. Should probably test it to make sure it works. Cool. Okay.
So I actually have a rough question for the daemon. So actually, in the current implementation, if the daemon is not started, then the librd can actually fall back to the original read path. So how do we? So for example, if RBD is actually reading normally, and then the daemon starts up, how can we inject this message to the current library to redirect those reads to the daemon?
Well, I imagine so. If you have the shared cache like object dispatch layer, if in the background it's periodically trying to establish that IPC connection, and then once it gets established, it can say, it's still in the cache layer, and if it says my state is I'm connected, I will actually send the IPC message. But if my state is not connected, it just forwards it to the next layer in the dispatch automatically. So.
I see.
It should be pretty transparent. Like if I configure my librd to say, hey, enable this cache plugin layer on startup of a cloned image, for the parent image layers, it would instantiate that dispatch layer, and that dispatch layer would be responsible for establishing the IPC to the daemon and restoring it if it fails, or any number of things. But basically, if state equals connected, try to forward it, and maybe even timeout if you don't hear a response back from the daemon in 20 milliseconds or something like that.
Okay, I see.
You're always safe, at least, that your default state is just forwarded to Rados. Nothing can happen.
And if it times out for any reason, then it could it'll just not try to talk to the daemon for some period of time, and then try again a minute or two later.
Yeah, go back to reconnecting.
Okay, I see. Thank you, Jason.
Sounds good. And it connects via a Unix domain socket in var run or something like that.
Oh, right. So currently we have an option for inside. So we have an option to define those the socket paths.
Yes.
It's currently in our, I think it's in temp or somewhere.
Yeah. Okay. So we probably want to just pick a location, because presumably you only run one of these per. Well, because the whatever the cache is has to have access to at least as much of Rados as RBD does. It's going to work, right?
Yes.
I guess yes. Not that much. But yeah, you probably just put it in by default it'd be var run ceph.
Okay.
Object cache or something .socket or whatever, I don't know. That's presumably only one per host. Yeah. Cool. Okay. Sounds good.
Or even if you did more than one per host for whatever reason, like in containers or something like that, you just map in.
Yeah. Just set the path to something else. But would you make librd by default just look for it and try to use it if it's there?
Currently we have currently we set that option to false. So you have to enable that option first.
There's probably some security thinking to do to make sure that if you do connect to it, that it's the right one. So you'd want to make sure that the socket file is owned by the Ceph user or something like that. Somebody can't impersonate it and give you bad data.
Yeah, well, at least
drop on your.
SC Linux will at least protect you from that, but yeah, if you don't.
Yeah.
If you label everything correctly.
Yep. Cool. All right. Sounds good. Anything else on that?
I think.
All right.
Yeah, I will check with Jason on the next plan.
Next steps. Cool. Okay. And the next one on the list here is RBD persistent write back cache.
Let's see. Is this microphone working?
Yep.
Oh, good. Okay. You never know. Okay. So Jason's heard about this quite a bit, but I don't know that you know the details of it. We we're working on a write-back cache for RBD, obviously, and this uses the image cache interface, which is at the other end of LibRBD. I can show you the basic layout here. I just gave a presentation on this at SDC to a bunch of people who, did everything go silent?
No, I can hear you.
Oh, that's funny. I clicked the share button. It's saying add a BlueJeans extension. Well, guess what? That's probably too late now, isn't it? Let's share add to Chrome. Let's see, this is going to make me restart this. That's not going to end well, is it? Well, I can do the slide there.
You got rooted by BlueJeans.
Yeah.
Oh.
Well, it's going to make you restart the browser, right?
Yeah. You just reload the page. It won't take that long.
Oh, really? Okay, let me go try that here. Well,
it's good. I just sent out the slides.
Okay.
Oh yeah, that works. Oh yeah, I put this on Steam. Oh yeah, let's just look at this.
Oops, what do I want to do here? I want to share this. It's all screens or nothing, huh? You can't just do. Apparently, I'm sharing my screen.
I see it.
You can see it. Okay. All right. So you see the ugly colors selected by PowerPoint for me. So can you see the pointer if I move the pointer around in it?
Lovely SDC slide template. Yep.
Right. Yeah. So, it's a miracle I could get these slides done. So, much less make some others with an Intel template. So there's the layout of the moving parts, which probably aren't very surprising. We're interested in having your write-back cache be persistent and have it be replicated so you can survive a failure of a node, obviously. What we're specifically doing, because we had a use case that matched up to it and it seemed to fit with general community need here, is for this to be in 3D Crosspoint. The advantage of the 3D Crosspoint being that this replica, right, if you can see that mouse wiggling, is a hardware data path. So, that keeps obviously the latency nice and predictable. But as we talked to some customers at Cephalonicon, we discovered that their OSD nodes are often out of CPU cycles. So they couldn't even consider using a write-back cache if it meant running more stuff on their OSD nodes. People ask, well, gee, why can't you put the replica in the client? And well, we could. When I started this, I made the assumption that, we know whether an OSD node is coming back. We don't know whether client nodes are ever coming back. So, so naturally, you'd like to be able to answer the question, are the writes to this volume lost forever or not? And if the replica is on an OSD node, then you at least have a story there. Let's see. Everyone's still there? Because now it's strangely silent.
Yep.
Oh, right. BlueJeans helpfully turns the screen black so that I can't see a thing after this. So, all right. So none of this is probably very surprising to you. As it turns out, as I've learned more about Ceph, it seems like maybe it's not such a big deal to put it in the client. But in the interest of actually getting something done, I haven't gone back and worked on that. Let's concentrate on getting something working here first. So the deal here is obviously we're going to write to this log and then we're going to promise to flush it later. And so what we're showing here is that normally you're going to flush from the client node. If the client node dies, you'll flush from the replica. We explored early on the question, wouldn't it make more sense maybe to flush it from the replica? If you're going to put the replica on an OSD node and the OSD nodes are on dual networks, but maybe your client isn't, it's maybe only on an application traffic type network, maybe it would make more sense to flush from there. I guess that depends on your cluster, but we have this restriction that the current implementation of PMDK doesn't allow replicas to be read. Now, that may not be a permanent restriction, but I probably just jumped ahead here. We were able to save a lot of complexity and make the Ceph code a lot simpler, which some people were pleased about, by using the PMDK pool replication feature. So the advantage of that is that the code here in the write-back cache is dealing with persistent memory operations using the transaction mechanism to make atomic changes to the write log. And when that pool is configured to be a replicated pool, those persist and allocation transactions, they apply to both pools, and they're applied to the remote one with RDMA writes and the occasional other special operation to guarantee that it's persistent. The other beautiful thing about it is that what you have to do for persistence and remote persistence is very platform dependent, and so we really don't want that in Ceph or any application ever. So we really want to use it. So as Jason can tell you, one of the struggles is I would really like the RWL to use the installed PMDK on the node to get the benefit of that. But this led to, you really need to make your image cache into a plugin because we don't want to have PMDK installed to be able to install Ceph, or a Ceph client, which is perfectly reasonable. But that's kind of not something I plan to do. I mean, I'm planning to do it now, but clearly it's not done. So trying to skip over the stuff that, this FCC presentation for people that may or may not actually know about Ceph. Lots of them had seen, and they didn't. So yeah, so you guys know about all that. So the thing that might be surprising about how this stuff is laid out versus if you were doing this in an SSD is that you've got pointers, and you can touch tiny regions of PMEM for it isn't painful like it would be on an SSD, and so considering what the performance target here, the primary use case we're after first is this tail latency thing, so that you can have, for instance, a CSP with a VM image backed on RBD, and they can get tail latency low enough that you can do a bunch of writes to your file system for your customer's VM in a nice predictable amount of time. And the data that we've measured, and I'm sure everybody knows, it depends on what how your Ceph cluster is deployed and what hardware it runs on. But even if you use flash everywhere, there's still variable write latency. Obviously, there's a lot of moving parts, and the whole point of Ceph obviously is that it keeps working even when the parts aren't healthy. If you got a big enough cluster, something's always broken all the time, right? So that means there's basically tail latency is sort of a way of life based in an operating, we assume. So this is the small end of the performance envelope. You don't need very much cache. You're really only after making it nice and predictable, and for workloads that are kind of modest. So we targeted, when we talk about this, we targeted what a low end VM from a CSP or what your Amazon VM might do, which is a few thousand 4K writes a second. They just want to be able to get 9.99% of those done in less than 3 milliseconds, so that if you've got to do 8 or 10 of them, it can be done in a reasonable amount of time. So the other end of the performance curve, which is kind of where I was focused when I started this, because that's the universe I came from, is the let's make it run blindingly fast forever, even if you can't flush. So that's one of the motivations for having these data buffers allocated separately, because then here's an example of an overwrite. That means you can free this thing, and because it's PMEM, that's pretty cheap. It basically it's so that's where we're going there. I had hoped that this would actually work maybe reasonably well on an SSD without modification, and I've got data now that shows that no, it just doesn't. So I mean, it does work on SSDs. You can test it that way, but oh my God! So it actually helps average write latency for some, my toy cluster in the lab, but the tail latency is just dramatically worse. So because you're making all these flush calls. So okay, all right, so couple of things. The get forward here to you don't care what's going to happen in a persista, right? But okay, so this data path is.
Could we look at 12 and 13? Actually, I'm kind of curious what these failure modes look like.
Oh, okay. So just so there's your client dies, in which case your replica takes over everything. And this, so the PMBK transactions mean, they handle all those nasty edges. If your write didn't complete back to the client, then or if it was in flight when something died, then when the power comes back on in the building, it's erased from history, which is the result that you want. And here's the other cases like the entire replica goes away, or just the NVDIM there goes away, which as far as we the client are concerned and the rest of the cluster that has to replace it, these are the same thing. Let's see, what did I do here? There's this other thing where so it's kind of an unfortunate fact of persistent memory now that if that NVDIM fails, your node probably goes with it. You'll get a machine check, and it's bad news. So that might not be true forever. But right now it is. So the thing is, if a local media failure is going to kill you, well then you don't really have to handle that case. So the bottom line is that in the RWL it means that we can be if we know that we're going to get a machine check. If the media fails, then we can complete user rights even a little bit sooner than otherwise. We don't really have to wait for the remote persist. Anyway, so actually, I've backed off from that position because this is a thing that could happen. It's not a thing that's guaranteed to happen. So if you could survive it, then you'll have to handle it. Just trying to skip forward to this is what we had in mind for the performance that we're for this tail latency case, really modest. And then we built the thing and the data path for it anyway, and it does it. So we can hit that goal. So it's an open question whether we can go to the high performance case, and there's a number of management sort of issues that are a problem there. Enormous caches take a long time to flush and a long time to resilver. Those are unhappy things for users to have to. Well, their users are really unhappy if they're surprised by that. So unfortunately, a snapshot pretty much requires a flush because the Ceph snapshot API is synchronous, and as far as I know, there's no plans to make that asynchronous. But once this is done and working and we see whether people can use it, I'd like to revisit that question about maybe making snapshots async or doing them through the cache. And then maybe we can entertain this notion of higher IOPS. Obviously, you have to be able to flush out of order, which is not going to be acceptable to some users. That's just the way it is, right? If they're doing mirroring, there's no other way. I talked to Jason about this earlier, saying, well, gee, what about a series of snapshots made on the volume and then deleted, and we could just opportunistically create these. But then he, gave me the bad news that deleting all those snapshots is incredibly expensive. So unless that's going to change, that's. So
can you jump back? Page up, I think it's like slide 8 or slide 7, I can't remember. Go up the slide 10, I guess it is. Go to 10.
This one. This is what happens after an overwrite.
So this is, as you go down this table, you're going forward in time, right? LBLU 0 was written and then 16 was written and then 0.
Right.
Okay,
we're not doing this right now.
Okay. I think you can't do this.
We can't do it if you want to do ordered write.
Yes, I think write back has to be ordered, period, because otherwise
this was
the image in the cluster won't be point in time consistent. And so if you've only partially replayed your write log and then you lose your write log, then you corrupted your image.
It's bad, right? We got this message. This was made very clear that we consider it a community requirement that we have to support ordered write back. But we understand that we can
Well,
configure
across
that more.
flush barriers, right?
All right, your max headroom there. That audio was really bad.
I'm sorry, I was saying, like,
yeah, go ahead.
Within the same like flush like epic, you're free to out of order retire, right? Because as long if someone's doing a flush, then that's kind of your barrier saying you can't reorder past, you can't do out of order retirement.
Sure,
past
I
that.
suppose.
Right.
Yeah, but we, you know, I have
As long as
no
they don't
data
overlap.
on this. I have no idea. Yeah, right. Overlaps and stuff like that are kind of a source of most of the complexity of this thing, as it turns out. So, as is, here was a big surprise. I thought, okay, fine, I'll give you guys the order right back flushing. That should be easy, and then I can get on to my optimized flusher and see how awesome it is. And then I discovered that a naive approach to order right back flushing turns whatever QDEP you had into one, and that's just awful. So
Right.
I had to, what time I expected, recording clues about observed write concurrency. And so I do that now. It remains to be seen whether that needs to be more aggressive. So one of my questions kind of hanging out there is about the nature of the user mode timer mechanism, if we have sub-millisecond timers that are reliable or not. Because
again, you're recording hints about the concurrency in the workload?
Yeah, let's see. Do I have a diagram of what the sync point thing is? I don't think I actually.
Because I think Jason is right. Like, as long as you record the flush events in the log, then as long as you know that there's another flush event, like 3,000 IOs in the future, you can write all 3,000 of those all at once. Unless
but what's the likelihood we're going to get 3,000 IOs between flushes? I mean, if you're going to get flushes from an application, it's because your block layers, doing the file system said, okay, fine, this is a what does the Linux block layer call that? The barrier before and after thing, which really turns into a flush when it goes out to the disk. So, basically all the writes for the files.
In reality, you're going to have more than one IO between flushes, hopefully, unless you're like, it's literally like just a journal. But if that's the case, then like you really have to like go in order, right? Like if you're doing one IO, if the client is doing one write and then a flush and then a write and then a flush and then a write and then a flush.
Yeah,
that's the
word.
Like I don't know that you can do anything about that.
Yes. To deliver ordered write back, that's what we would have to do. We can't make it any more parallel than that.
Right.
If the user relaxes the ordered write back requirement, then we're free to do other things. But so far, we don't have a mechanism to relax that. And your position is that no one will ever want to do that.
I don't think you can.
The people that mount librd will like in QEMU with the unsafe cache, or just disables all flushes.
Yeah.
Well, I mean, so if you believe the replicated write back log was that it was reliable, that your replicas would save you if something died, then where you'd be more comfortable. Unless you're doing like remote mirroring, then I think you're stuck. And there may be other volume features that I don't understand that would also mean that you're stuck. But for the usage models that I can think of. So anyway, yeah, right. We're going, obviously, ordered write back is the only thing that's implemented right now because that turned out to be enough work.
Yeah. I guess my gut says that that's the safe path. There's like a tangent where maybe they'll want to like disable that, but I'm not sure about that. But there's also this other sort of possibility that they don't have 3D crosspoint DIMMs in multiple machines and an RDMA fabric attaching their clients to their servers, which I think is like everyone in the world except you right now.
You'd be happy to sell you. Yes, and it's been asked that it work on SSDs too, brother.
Right. So, and if you think about the rest of the world, then if you could make this part here so that the module just abstract it just enough so that the bit that's like deciding how to write it into persistent memory could instead write a sequential stream of bytes to an SSD, then they would get a big boost. It's not going to be as big, obviously, as they would if they're doing a write back into 3D Crosspoint, but it'll be pretty good.
Yeah,
And they won't need the replication at all, right?
Well, I would disagree, but
if they do,
but
if they
it'll be
do order
useful
right
without
back.
replication.
So
if you don't need the replication to get you durability if you are doing ordered write back. Yes.
Right.
But
so
you also can't exceed that.
The theory, whatever, is that there is a large class of users where if you lose your client host, which is a rare event, but if you do, or it fails over or whatever, it's okay to warp it back in time a few seconds and fail over with a point-in-time consistent copy from a couple of seconds back on another node, because you're only lost like 2 seconds of data and you didn't like corrupt the whole volume. That won't work obviously for database in like a whole big stack or whatever, but like for all the VMs that are like just random other shit that's scribbling all over their drive, like in your cloud platform.
I'd be really unhappy if the server in the Amazon cloud did that, but that's me. So, it's accepted email message and recorded act to the other end and it's delivered and then oops, it's not. So
right.
That's
so like if it's a server, if it's like some service that's like making promises to clients, yes. But if it's like a VM where I'm like Jenkins, it's doing builds.
Yeah, right. It's crashes,
the
service thing.
It's the whole thing. Who cares?
Right.
Yeah.
We talked to guys at CERN that they're maybe I shouldn't mention customer's name, but scientists do this kind of stuff, and their workloads are restartable. Right. I think in part because they're staffed by graduate students, and their time is free. So,
yeah.
But that's just a theory. But it's all experimental anyway. And they're faster is better. We understand that. We're not trying to, take away ordered write back. We're definitely going to support that.
Okay.
But the reality is that everybody's going to want more performance than your Ceph cluster can deliver. And the only way that I see to do that is basically is with a cache like this. In previous life, we saw VDI instances that, were running the proprietary OS that aggressively trimmed. It would, write a bunch of files, and then when it was done with those, it would actually send down the trims. So if you could afford to have a large enough write back buffer, there's a bunch of stuff you'd never have to flush because eventually it gets discarded. So that's, one of the hopes is you can, quote unquote, improve your cluster performance by not writing stuff to it because you'll wait long enough to find out which things they don't need. But yes, that you definitely need replication, and replication pretty much needs RDMA, otherwise it's too expensive or it doesn't help because it's too unpredictable on the other end. And we understand the need for SSD support, and I'm trying to get that into the schedule here. And so this is the first thing I ever wrote in C++, and it turns out I did it wrong, and it's going to be a little awkward to factor out the bottom end for SSD. Yeah, so
that works. So I guess
we get that.
My like overarching question, I guess, is the interface into the cache abstractable or modularizable or whatever, such that you can have two implementations, one of them that does, Apache pass across RDMA, and the other one that's like writing to a local NVMe device.
I don't know what that pass was you just talked about, but
yeah, whatever. Sorry.
But so there's two places to ask that question. So there's the image cache interface that Jason came up with, and we've been using that, and there's some things maybe that we can that maybe should be common. Like for instance, the fact that you really want to discover which writes overlap before you decide, before you start trying to persist them. If we're going to have multiple versions of image caches, maybe that should be factored out. I would certainly do that inside RWL if I was going to make, say, the back end just a separate pluggable thing. That wouldn't be the image cache interface. It would just be a plug-in to the back of this. But another way of looking at that is to say, let's just learn from this and pull these classes out and then change what the image cache interface is so that it's lower level. Another weird thing is all these interfaces give you extent vectors or extent lists, and there's no guarantee that they're contiguous or in order or even not overlapping. And I've got this to-do item to basically massage that vector that comes in the top of the RWL, because what you just pointed out, writes between flushes, in theory, I'm free to reorder those, unless some of them overlap. I'm kind of assuming right now that they don't overlap.
They usually won't, but they can.
Yeah, they usually won't. I think we end up, what really happens in RWL is I've got this block guard thing that I adapted from somebody else's implementation of a block guard and had to stare at for like 2 days to convince myself it actually worked, because it seems kind of anyway, spooky. But it's when a write is deferred because of the block guard, then we will create a synthetic sync point for it when it comes out. So AIO flushes, the RBD AIO flushes, always produce a log entry called the sync point, but we can produce sync points for other reasons, like say you crashed or you're closing the image or various other things. And this sort of observed overlap is another one of those. We also don't want, because sync points are granularity for retiring entries, they're going to be our granularity for synchronizing with the replica. If I didn't have PMDK pool replication, they were also the mechanism for resynchronizing the replicas when they came back up. But I'm happy to report that I don't have to do any of that. None of that complexity is in this because it's handled for us.
That's pretty nice.
But anyway, so there's a lot of uses for sync points, and that's one of them. And what was I going to say? So that's kind of a question. When the plan of record is to just do the pluggable backend for RWL thing, so we can get SSD support for the community at some point here, hopefully soon. That architecturally might actually not be the most beautiful solution. So if you'd like to do it a different way, let's talk about that. So what's the other surprising thing here was, Jason, I don't know if you intended the image cache interface to be stackable, but it sort of trivially is. So I guess we talked about that in the way to configure image cache plugins. Basically, just the user will just give you a list and you'll create them in that order. Since I had to go back and enable and make, so RWL used to be just enabled with a config option, and there was really only one image cache that would ever exist. But when I hit some nasty stuff with the unit tests, that there was suddenly 10,000 unit tests that needed to test for the existence of an image cache, because those operations just really didn't make sense with an image cache. That's not coherent shared access. Anyway, so now the image cache is enabled and disabled during the exclusive lock acquire and release phase. And so turns out I had to go and create all the logic to persist the cache configuration. So this notion of stackable image caches is sort of accreting stuff around it. And so now would be the time, if you thought we didn't want that to be the case, to
what would be the point of stacking them?
Just, how every engineer wants to make everything, future-proof, right? So you could, for instance, use RWL with a tiny amount of PMEM to get your tail latency, and then stack it on top of a bigger, cheaper write-back cache to get your high IOPS use case out of the way. If you wanted to have a 70,000 IOPS database machine that ran.
Yeah. I see.
Yeah.
Okay.
So whether that makes sense or not, I don't know. I used to think that would be how you would get an image-specific read cache, because there's kind of a gap in this architecture, right? This RWL only caches the things you wrote for this image. And Yuan's cache only caches the things in the parent images that are immutable.
Right.
And so anything you've changed in your image, and if you're a database, that's everything, right, is not cached. So all reads that obviously, goes without saying that the RWL has to be readable, right? Because you're right. Yeah. We've told you it's done. We haven't flushed it yet, and you might want to come back and read that. How likely is that? I don't know. But it has to be supported. So I used to think we would do this by stacking image caches, but now it seems like the object dispatcher is a better place to do that. So, so I'm just throwing that out there because it's kind of a blob of, it must be 10% as much code dealing with that as there is the actual data path for this thing.
Yep.
So,
okay.
Right. So,
well, it sounds cool.
Where are we with?
Sorry,
where are we with the Nautilus merge window?
It's February.
Pretty much.
And I can't remember. So the freeze is going to be. Can't remember if the freeze is going to be beginning of February, I think, or end of February. I can't remember. You go back and look at this. Look at the calendar. But something like that.
I thought I was already late. Because I told Jason in March that I'd be done in September, and well, here it is November. So
yeah.
Then life happens. Yeah.
Yeah. Right.
Yeah. Well, it sounds to me like they're like kind of in order to tile this together, there are a couple things. One, there needs to be some sort of like persistent record on the image that there does exist a write back cache on the client, some identifier on it, so that there's like a force function that would have to be used to like make that detachment if it wasn't completely flushed, so that when the client, if the cache is lost, you can sort of cut your losses and roll back in time. So there's that whole infrastructure. And then the other thing would be, I think this needs to have, or ideally should have that abstraction sitting above the PMEM part, so that you can have a different implementation that's targeting an SSD.
Right.
I don't know that you have to implement the second one, but we should just make sure it's written in such a way that we can sort of interject that layer there. Otherwise, I think this is going to have a very narrow audience.
Because people don't have the hardware to do this yet, except us, right? That's
right.
Yeah, we're getting ready for what we hope is the glorious future here. So in the meantime, it has to help people that have stuff now, right? Yeah. That is the plan. But whether I can actually execute that plan remains to be seen.
Yeah. All right. Well, might make sense to speak up with Jason. I don't know. Jason, have you been reviewing the code? I haven't looked at the code for any of this stuff at all.
In fits and spurts, yes.
Yeah.
Okay. So I have now added the stuff to persist the fact that there is a stack of image caches, and there's some bits in there that tell you whether anything exists on those nodes. Did they actually make any files there? Do those files have any writes in them, and are any of those writes unflushed? You can tell all of those things when you open it, and you can decide at open time, it's dirty, I'm not going to let you open it, which is what it does now. You maybe don't want to open it even if it exists, because if you don't clean it up now, then who's going to clean it up ever, really? So what's missing is I haven't done any of the CLI stuff to basically abandon the cache.
Yeah.
So I'm not quite sure what that should look like. What if they're? I'll stare at that RBD.
Yeah.
It's going to be an RBD thing, right? The awkward thing is that. Yeah, so here's the situation. You might, say, I want to disable image cache, but it's got a dirty cache on some other node. Well, it'd be pretty weird you wouldn't really expect that tool to try and access that remote node and flush that cache for you, right? You'd probably rather it just said, go to that node and do this again.
Mm-hmm.
Okay, so we won't try to do any cute SSH thing or anything like that.
No, yeah. I think that there should be a command that we'll just flush the local cache, and then when the flushing is complete, it'll sort of detach or record that it's flushed, whatever that looks like.
Happily, that all happens by accident. If you say disable the cache and you're on a node that has the cache, it has to open the image, and if it opens the image, it opens the cache, and then when it closes it, it's flushed. So it's only a problem if you do it on the wrong node.
And then there'd just be a command that says abandon the cache, and it'll just detach it. And then if somebody tries to open it, it'll refuse because it has a local cache.
Because it's got the feature bit. Right. Yeah. Or
or
you're the kernel client. You don't know what the feature bit means, and so you just can't open it.
Yeah.
That was happy to find that.
Or if I mean, if say you have a write back cache, the node crashes, somebody on another node detaches it, but then the node comes back up, and you try to like open it, it should refuse because the image doesn't say that it's attached to that cache, but the cache has data in it.
I would
So
expect it wouldn't even look for the cache, and that's the problem. You'd like it to go and say, well, let's look in the directory that's supposed to have cache files in them and see if any of these are not associated with a volume anymore, and throw them away.
Okay, that sounds fine. What you suggest actually sounds fine. Yeah.
So it'd be kind of nice if there was a way to like leave a clue behind, but I don't want to like throw a bunch of things in this KV store so that so that basically anybody that opened an image there could say, yeah, there's a bunch of stuff I should delete, but
you could have a garbage collection thing, whatever. Yeah, that's later.
So one of the problems with replica selection, we always assumed that we're going to have a beautiful cluster that has 2 RDMA fabrics and everything's connected, and you don't care which node you choose for your replica as long as it's got PMEM. You do have to remember which one it was, obviously, and always go back there. But the ugly truth is that a lot of people are going to have Rocky just in their rack, and they're going to have several racks, and so we're going to need more information about the candidates for where replicas go. And I don't think connectivity is currently monitored. It's not a thing that the cluster map really knows about, right? Islands of RDMA connectivity or islands of connectivity on certain subnets. Is that a thing?
Yeah, that's not really.
You can discover?
It's sort of assumed that there's a complete fabric generally.
It's flat, right? Yeah, but then you got this property, this magic RDMA property, which might not reach outside your rack. So, okay, all right, well, so what we're looking at here is the data path for this is done for a single node without replication because FS Stacks isn't baked yet, and there's some things missing from PMDK that let us steer replication during runtime. And since most users probably aren't going to care about that unless they're coming along with our use case, we're hoping to do that in a follow-on patch. So you won't see that now. There's no daemon for handling the replicas now because pieces are missing.
Okay.
Oh, all right. Well, that's it.
All
and thanks for.
Yeah, thanks. It's gonna be exciting. All right. Well, I think that's basically it. I had a couple items on here to just give an update on the orchestrator and the messenger stuff. On the orchestrator stuff, I think Tim probably the only one who cares, and you know more than I do anyway because you're joining the calls and I'm not, so we'll skip that.
Fair enough.
The messenger 2 piece, it's a short update. The next pull request to merge has a sort of a strawman placeholder implementation of protocol v2 that doesn't do anything different than the first version really, except exchange multiple addresses. And then there's a whole pile of patches that just fix all the OSD map structures, the MGS map, the MON map, and related commands to deal with having multiple address endpoints for a single entity. So each monitor will have a V1 and a V2 address. Each OSD will have a V1 and a V2 address, and all the machinery just to like put all that stuff in the map. And so that's the next piece to get through. In parallel, Ricard is working on the actual protocol v2 implementation based on the one that's currently spec'd out in the document. And then also in parallel, Daniel's working on some of the initial Kerberos pieces. And then the last piece is I have an email that I need to get back to from Bill Simpson, who did sort of a high-level review of the protocol design. He's done worked on a bazillion IETF protocol designs ever since FTP, I think was his first one forever ago. So he's been around a while. And so he has just a bunch of suggestions about how to structure the protocol to not make any dumb mistakes. So I need to go back and reread that and apply that to the current design, see what we want to change. But that's about it. Sort of creeping forward. Need to hopefully accelerate that a little bit because once the protocol v2 is sort of there, we need to add the encryption piece. That's sort of the main high-level user visible feature deliverable that we need to get in, and then glue in the Kerberos stuff in a way that lets it coexist with FX. That's going to be sort of some refactoring in the auth code, make it sort of authenticate with Kerberos and then give you Cephx tickets to talk to the cluster. Be a little bit tricky, but yeah, that's about it. Anybody have any other questions, topics? All right. Have a good one, guys.
Later.
Take care.
Thanks, everyone.